let's now consider this probability problem involving a system of electrical components. To begin, let's draw the system. So I have two parallel systems, A and B. So there's one system up here, A, and one system down here, B. The easy one is actually B. Let me do that first. So there's a component 4 and a component 5, which are in series. So they come one after the other. Subsystem A consists of component 1 and then subsystem C in series. So I have a system here that comes after 1. And subsystem C consists of two things that occur in parallel. Okay, so there is our system of electrical components drawn according to the components of the problem. The components work independently of each other so that the probability that each component works is 0.95. Find the probability that the system works. So let's take this one at a time. So let's start going bottom to the top. The probability that C works, the probability that component C works, is going to be the probability that, well, component 4 has to work. So C sub 4, component 4 has to work, and component 5 has to work. They both have to work in order for the bottom to work, component C, subsystem C. And so by our multiplication rule, this is going to be equal to the probability that component 4 works times the probability that component 5 works. And because of independence, well, that's going to be 0.95 squared. And 0.95 squared is 0.9025. Okay, now let's work out subsystem B. Subsystem B works if either one of them works. If component 2 works or component 3 works. If component 2 works or component 3 works, then subsystem C will work. So I get the probability of C2 plus the probability of C3 minus the probability that they both work. So this works out to be 0.95 plus 0.95 minus the probability that they both work, which will be 0.95 squared again. And so doing the arithmetic, 0.95 plus 0.95 minus 0.9025 gives 0.9975. Okay, you should convince yourself that it makes sense that probability C, that the bottom subsystem, this number is less than 0.95 because they both have to work. Whereas for subsystem B here, this part is bigger than 0.95 because either one could work and would be all right. Okay, let me clear off some space at the top of the screen. Next, let's take a look at subsystem A. Subsystem A works as long as component 1 works and B works because they're in series. So that's multiplication, so 0.95 times 0.9975 so multiplying we get 0.947625. And finally, the whole system works if A works or B works. So by our addition rule, that's the probability of A working plus the probability of B working minus the probability of A and B Okay, probability of A is 0.947625. The probability of B working is 0.9025. And by independence, the probability that they both work is going to be the product of those two numbers. 947625 times 0.9025. So let me put a blue line here to make this a little bit easier to read. And so the answer will be just simply doing the arithmetic. 0.947625 plus 0.9025 minus 0.947625 times 0.9025 gives me 0.994893 accurate to 6 decimal places. So that's the probability that the entire system works.